Oh, well. So remember, f of g of x represents composition. F of g of x represents to multiply. This is to what we call compose. And basically what I mean by composing is you're going to take the g of x function and you're going to plug it into the f of x function, right? Just like we did last problem. So I'm going to take whatever g of x equals, and I'm going to plug it into my f of x function. Now, this is usually better understood if I can color code this. So g of x equals x plus 1, right? So all this is basically saying is I'm going to take my f of x function, which is 3, and instead of using x, I'm going to use g of x. Well, what is g of x equal to? G of x is equal to x plus 1. So it's really going to be 3 times x plus 1 plus 2. Now, apply distributive property. 3x plus 3 plus 2, 3x plus 5. OK? Now, did they ask for a domain and range? Or we had to evaluate, right? So we had to evaluate. They want you to evaluate for 3. So just like you would do, f of x, if f of x equaled 3x plus 5, and I said f of 3, you would plug in 3 in for x. Well, now they're just saying, what was the composition? And then evaluate for 3. So the composition of this is 3x plus 5. And now they want you to evaluate it for 3. So again, you just plug 3 in for x. So we can say that the composition of f plus g, or f of g, of 3 is equal to 14. Any questions? Make sense? Just for fun, what would be the domain of 3x plus 5? Anybody?
Does it have to equal 0?
Nope. What do you think? No. What do you think? OK, well, let me ask you a question. Is there any number that you cannot plug in for x and that you cannot multiply by 3 or add 5 to it? No. So there's no restrictions, right? So I heard a lot of people rumbling. Yeah, it's all real numbers. Negative infinity to infinity. Remember that the domain is only restricted, what we've talked about so far, our domain is only restricted by dividing by 0 or taking the square root of a negative number. When you don't see that, your domain is going to be all real numbers. Yes?